In chapter 3, we talked about increasing and decreasing functions, relative extrema. We had the other sections that were talking about concavity, inflection points, and so on. I'll start with chapter 3 and give a quick review for chapter 3, the beginnings, because we have studied those. And then I will keep moving on the other sections and explain it in more detail. The very first thing that we have got in chapter 3 is talking about increasing and decreasing functions. What is an increasing function and what is a decreasing functions? In general, talking generally, I mean, if we have got a function, for example, let's consider f of x, that's equal to x squared. And let me sketch the graph of x squared. As we all know, the graph of x squared is like that. Sorry. Generally talking, we say that if we move from left to right, okay, if we move from left to right, if the function is falling, okay, if the function is falling, we say that the function is decreasing, okay, the function is decreasing. What does falling mean? That means the slope of the function in that period is falling, is negative. For example, if you have got a point here, if we draw a tangent line from here, if you look at that, the slope of that tangent line, you see that it is negative, it is falling. That means the function is decreasing. The same thing if we take a point from here, and if we draw a tangent line from here, we see that the slope of this one is also negative. That means it is falling. That means the function is decreasing. But from this point onward, if we look at the function and if we move from left to right, okay, again, if we are moving from left to right, you see that the function is rising, okay, rising. That means the function is increasing, okay. When we say that the function is rising, that means that the function is increasing. What does increasing mean? That means if we take any point on the graph of the function, when we are drawing a tangent line, the slope of that tangent line is positive. Wherever we are taking a tangent line, a point, and we are drawing a tangent line, the slope of that tangent line is positive. What does it mean if a slope is positive? That means it is rising. What does rising mean? That means the function is increasing. So generally talking, if you look at the function x squared, that function is decreasing from minus negative infinity to 0 till here. It is decreasing from this period till here. It is decreasing, okay. And if we look at the function, the same function, it is increasing from 0 to infinity. From here to there, it is increasing, okay. That's generally talking. Let's come to mathematics. I mean, let us define it in a mathematical way. If we have got that function, we say that the function f of x is increasing, okay, if f of x2 is greater than f of x1 whenever x2 is greater than x1. And we say that, of course, f of x is decreasing, okay, if f of x2 is less than f of x1 whenever x2 is greater than x1. If you look at those definitions, x2 is greater than x1. If you have got f of x2 is also greater than f of x1, that means the function is increasing. Let's pick a number from 0 to infinity. Let's pick, two numbers from 0 to infinity and apply that definition on it. If you have got x1, that's equal to, for example, 1, or let's consider it as 2, and x2 let us consider that it is equal to 3. Here we have got x2 is greater than x1. Okay, 3 is greater than 2. Let us find f of x1. F of x1 is equal to what? Since the function is x squared, if you put 2 in the x squared, that will be 2 squared, and that's equal to 4. And if you want to find that function, f of x2, if you put 3 into that function, what will we get? That we will get 3 squared, and that's equal to 9. If you look at f of x2 and f of x1, which one is greater? Of course, 9 is greater than 4. 9 is greater than 4. What does that mean? That means, okay, f of x2 is greater than f of x1. Look here, what do we have got? Look at here and there. x2 is greater than x1. And what did we get? F of x2 is greater than f of x1. So from that period, from 0 to infinity, we see that the function is what? It is increasing. Why? Because of that rule. Let's consider, or let's take that part of the function from minus infinity to 0. Let's see what will happen. That was from 0 to infinity. We took the numbers. Let us consider the interval from negative infinity to 0. Let's consider x1 is equal to, say, minus 2, and x2 is equal to minus 3. If you look at here, which one is greater than the other? Of course, x2, or let me consider it like this one, x1, let it be minus 3, and that one, let it be 2. Okay, here if you look at this one, x2 is greater than x1, minus 2 is greater than minus 3. Let's find their f's. F of x1 is equal to what? If you put minus 3 into that function, we will get minus 3 all squared, that's equal to 9. And from here we get f of x2, that's equal to minus 2 all squared. Of course, the minus is inside the bracket. That's equal to 4. If you look at that one, that part, which one is greater than the other? F of x1 is greater than f of x2. Okay, what does that mean? If you look at this one, that means f of x2 is less than f of x1 if we rearrange it and put it like in this way. So what did we get? We got x2, we had x2 is greater than x1, but what did we get in that interval? We got f of x2 is less than f of x1. So what do we get from this one? We get that, according to the definition, we get that the function is decreasing in that interval, and considering that definition, we get that the function is increasing in that interval. Okay. Of course, for finding the increasing and decreasing intervals, we have got a procedure. Okay, what is the procedure? We have got step 1. Okay, we consider step 1 or number 1, anything that you want to call it. To find the increasing and decreasing intervals of a function, first we have to find the derivative of the function. Okay, when we find the derivative of the function, the first derivative of the function, then we have to find those numbers that makes the first derivative equal to 0 or undefined. Okay, f prime of x is equal to 0 or undefined, or maybe both of them occur in the question. Okay, and then what will we do? Then we will find, when we find those numbers, we will put those numbers on the real number line. For example, we get that f prime of c is equal to 0 and f prime of d is equal to 0 or undefined. It doesn't make a difference. We put that c and that d on the real number line. If you look at the real number line, it starts from negative infinity to positive infinity. When we are putting those numbers on the real number line, it divides the real number line into sub-intervals. Look, here we have got one interval, Here we have got an interval from C to D, and here we have got an interval from D to infinity. Then step 2, what will we do? Or you can consider finding the derivative the first step, finding those numbers that makes the first derivative equal to 0 or undefined the second step, putting those numbers the third step, and that one the fourth step, as you wish, as you like. Do whatever you like to do. Okay, then what will we do? We will take test numbers from each interval. Here we have got an interval, here we've got another, and there another interval. So take a test number from here, consider A, okay, A1 and A2. Look, I took a test number, any number that is less than C, and I take a number, any number that is between C and D, and I will take a test number that is any number greater than D, okay. Then what will we do? We will put those test numbers into the first derivative of the function. So f prime of A, I will find f prime of A1 and f prime of A2. I will find, that means I will put those test numbers. Here we found what? We took test numbers from each interval. Then we put those test numbers into the first derivative of the function that we've already found. If f prime is greater than 0, that means the function is increasing, okay. If it is less than 0, that means the function is decreasing, okay. If it is equal to 0, we cannot say that the function is either increasing or decreasing. We cannot say any of this, okay. Or we can say that when it is equal to 0, it is the critical number, or it is undefined at that point, okay. That's the procedure of finding the intervals of increase and decrease of a function. Then what do we have? Of course, I will make an example for you on that subject, okay. But let me first explain what a critical number is and what is relative extrema, okay? Because I have already explained these ones, and we have already made examples on those increasing and decreasing functions. Okay, let's come to relative extrema. That was what? The previous one was increasing and decreasing functions, and that one is relative extrema. What do we have in relative extrema? When I'm saying relative extrema, it includes relative maximum, and relative minimum, okay. So relative extrema is both of them, relative maximum and relative minimum. What is a relative maximum? What's relative minimum? If I have got something like this one, okay, I'll take that interval. I will look at that interval. If you see, this point is the minimum point or the maximum point. Of course, it is minimum, okay. So we say that that point is relative minimum. Now I'm coming to that interval, okay. I took from here to here, I got that relative minimum. Now I will take from here to there. If you look at that point, what is it? Is it a maximum point or a minimum point? Of course, it's a maximum point, so that one is relative maximum. Now I'm considering that interval from here to here. If you look at that point, what is it? It's again relative minimum. Again, if you take here, from here till here, that one is relative maximum. And of course, if I take from here to there, that one is relative minimum. That is in general what is a relative maximum and relative minimum. So coming to a mathematical definition, we say that relative minimum is the point where f of c is less than, look, it is less than any point, any other point that is in the interval. Okay, we say that relative minimum at point, for example, c. Okay, so we say that f of c is less than every other point. Okay, those points, it's less than every other point that is in that interval. How about relative maximum? We say that that point is relative maximum. For example, this point is D. We say that f of D is greater than f of x, where f of x is all the other points on that interval. Okay, so if I look at here, okay, if I look at here, those are all points in that interval. But which one is greatest? F of D is greater than all other points, all the other points. So that one is called the relative maximum. Okay, that was relative maximum, relative minimum. Both of them we said are called relative extrema. Let's come to critical numbers or critical points. What is a critical number? A critical number is a number in the domain of the function f. When either f prime of c is equal to 0 or undefined, or let me write it for you. Critical number is a number, okay, for example, is let's consider it as a in the domain of the function, such that f prime of a is equal to 0 or undefined, okay, or it does not exist. So what is a critical number? It is those numbers that makes the first derivative equal to 0 or undefined. And relative extrema occur at critical numbers, as we have talked about. Okay, let's move to the an example, or let me talk about the procedure of finding relative minimum and relative maximum. How do we find relative minimum and relative maximum? For finding relative minimum and relative maximum of a function, we are doing the same procedures that we did for finding the intervals of increase and decrease of a function. And we add one more step. So what do we have to do? We are finding the derivative of the function, okay, for finding the relative extrema. And then we are finding the critical numbers. That means we are finding those numbers that makes the first derivative equal to 0 or undefined or does not exist, whatever you want to call it, okay. Then we are putting those numbers on the real number line, okay, those numbers that we find, for example, c, and let me find it here. For example, c and d, we found those numbers, for example, that makes the first derivative equal to 0 or undefined. And then what are we going to do? We are choosing test numbers from each interval, as we said. For example, we are choosing a from here, a1 between c and d, and a2 greater than d. Then what shall we do? We are putting those test numbers in the first derivative of the function. Okay. If these ones are greater than 0, that means the function is increasing in that interval, okay? We say that it is increasing, as we talked about previously. If it is less than 0, look, a1 is between c and d. So since f prime of a1 is less than 0, that means the function is decreasing in that interval. And for example, if you have got f of a2 is greater than 0 like f of a1, that means the function is increasing, okay, in that interval. That's as a general example. Okay, that is the intervals of increase and decrease. But we were talking about relative extrema. How do we find relative extrema? The same procedure is done for finding relative extrema. We add one more step. What is that? We say that C and D become relative extrema if they change sign. Look here, when we say that that one is increasing, that means it's positive, we get positive values. When it is decreasing, we get negative values, and when it's increasing, we get increasing. Positive values, we get increasing. So we say that C is relative maximum. Why? Because on the left it's increasing and on the right it is decreasing. If you look at that function, look, from C, from that side of C it is increasing according to that one, and when it comes to that side it is decreasing. Here is what? Here is the peak. So that means that point C is relative maximum. Okay, let's look at D. D is relative minimum or relative maximum. Let's check it. On that side of D, the function is decreasing according to that, okay? It is decreasing. And on that side, according to here, it is increasing. What is that? That's a valley. So that one is the minimum point. So that one is relative minimum. That's how we find relative maximum and relative minimum. So we are doing the same procedures as for finding increasing and decreasing intervals, and we add one more step to check whether it is increasing from the left, decreasing on the right, or vice versa, and so on. But if you have got that case, for example, we have got C here, the function here is decreasing and here is decreasing, that one will not be a minimum point and will not be a maximum point. Or if you have got it is increasing and it is increasing, that point again is not relative extrema. Okay, it should change sign from increase to decrease or from decrease to increase, so that we can call it relative extrema. Okay, we are doing example 3.1.3. It says find all, let me write it for you, find all critical numbers of the function f of x that's equal to 2x to the power of 4 minus 4x squared plus 3. Okay, and then it says what? Classify each critical point as relative maximum or relative minimum, in general relative extrema, or neither. Okay, it is maybe the points that we find are maybe maximum points, minimum points, or none of them. Okay, so what shall we do? It is required from us to find critical numbers. Of course, doing those procedures, we are finding the critical numbers, we are finding increasing and decreasing intervals, and so on. Okay, let's do the solution. Start with the solution. What shall we do? The first step that we have to do is to find f prime of x. Okay, what is the derivative of that function? That's equal to 8x to the power of 3. As you know, when we are finding the derivative of this one, the 4 comes next to the 2. Okay, so that will be 8x to the power of 3. And then finding the derivative of this one, that will be minus, because of that minus, 2 will come down to 4, it will be 8x, and the derivative of 3 is 0. Okay, so the derivative of this function f of x is equal to 8x to the power of 3 minus 8x. Then we said, what shall we do next? We are finding the derivative, and then we are finding those numbers that makes the derivative of the function equal to 0 or undefined. Do we have anything here that makes the function undefined? No, of course we do not have. Why? Because whatever number we're inputting in that function makes it defined. It doesn't make a problem for us. So we do not have anything that makes it undefined. So what shall we do? We shall search for those numbers that makes the first derivative equal to 0. Let's find it. It's prime of x. Okay, we found the derivative, and then we are finding those numbers that makes the first derivative equal to 0. What does that mean? That means, sorry for that. That means 8x to the power of 3 minus 8x is equal to 0. How do you find this one? Of course, this one is an equation. We have to find the values of x. If you look at those two terms, what do you see in common? We see 8 is common between this term and that term, so that one will become 8. Okay, and if you look at those two terms again, x is also common. So what remains here? X squared remains here, minus, we have taken 8x all out, so 1 remains in here. That's equal to 0. If you look at that equation, we get 8x, x minus 1, because this one opens as a bracket, okay? It's expanded, that will become 8x multiplied to x minus 1, x plus 1 is equal to 0. We've got this one, and that one, all equal to 0, so 8x is equal to 0, or x minus 1 is equal to 0, okay, or x plus 1 is equal to 0. You know that if you have got a multiplied to b multiplied to c, that's equal to 0, a is equal to 0, or b is equal to 0, or c is equal to 0. That is the basics of mathematics, as you know. So x is equal to 0 when we're solving that linear equation. X is equal to 1 and x is equal to minus 1. What are those numbers that we found? These are the critical numbers. Do not forget that, okay? This number with that number with that number are called what? Critical numbers. As I told you, you have to write that these ones are critical numbers. You have to mention it. If you will not mention it, that will be considered as a mistake. Why? Because I'm asking for critical numbers, okay? So since you found them, if you leave it just like that without mentioning their names, how shall I know that you already know that these ones are critical numbers? So please, when you are finding those numbers, okay, write or mention their names. That ones are called critical numbers. Why these ones are called critical numbers? Because these ones, x is equal to 0. If you put it in the first derivative of the function, it is equal to 0. If you put 1 into that function, it makes it equal to 0. And if you put minus 1 into that function, it will equal it to 0. Okay. Then, okay, critical numbers. And then it says what? Classify each critical number as a relative extrema. What does that mean? That means check whether those critical numbers are relative maximum, relative minimum, or none. We said when we are finding those critical numbers from here, the procedure, okay, we are finding the critical numbers. Where shall we put the critical numbers? We shall put them on the real number line, okay? So I'm putting those numbers on the real number line. What do we have? We have got minus 1, okay? We're putting minus 1 here. We're putting, then we have got 0 and 1. We have got 0 as a critical number and 1 as a critical number, okay? We are putting those critical numbers on the real number line. Then what shall we do? We shall choose test numbers, okay? When we're putting the critical numbers on the real number line, we're putting test numbers. We're choosing test numbers from each interval, and then we're putting the test numbers in the first derivative of the function. So let's choose a number that's less than minus 1. We will consider it minus 2. You can also consider minus 3, minus 4, but minus 2 is the easiest. A number that's between minus 1 and 0, choose minus half. Okay? Please do not put those numbers on the real number line, because these ones are the test numbers. Okay, a number between 0 and 1, let's choose half, and the number greater than 1, let's choose 2. As I told you, you can choose any other numbers, but that ones are the easiest ones to deal with. Now, what shall we do? We shall put those test numbers in the first derivative of the function. So f prime of minus 2 we have to find f prime of half, minus half I mean. We have to find f prime of half, and we have to find f prime of 2. Okay. Considering f prime is equal to h of x, x minus 1, x plus 1. If I put, of course, when we are finding these ones, I do not care about the value. What will I get at the end? I care about the sign of that f prime of minus 2. That means I will check whether it is positive or negative. I don't care about anything else, because I just need to know whether it is greater than 0 or less than 0. Okay? Okay. Let's put minus 2 into here. If I put minus 2 into here, what will I get? I'll get negative. Okay? I'll get negative, because 8 multiplied to negative 2, it is negative. If I put minus 2 into that bracket, what will I get? Negative 2, negative 1, that's again a negative number. If I put negative here, I will get negative 2 plus 1, that's again a negative number. Okay? Look, we put minus 2 in here. That's 8 multiplied to minus 2. I will get a negative number. I put negative 2 in here. So negative 2, negative 1 is a negative number. And then I put the negative 2 into here. I will again get a negative number. Negative multiplied to negative is positive. Multiplied to a negative, it is negative. So whatever number we have got here is negative. What does negative mean? That means the function is decreasing. Okay, we got negative from that interval. That means the function is decreasing. Now we're putting negative half into that function. If you put negative half into that function, what will we get? 8 multiplied to negative half, it is negative. Negative half, negative 1 is what? It is negative. Negative half plus 1 is equal to what? If I've got 1, take negative, take away half from it, it is a positive number. So that one is positive. Negative multiplied to negative is positive. Positive multiplied to positive is positive. What does that mean? That means that interval, from that interval, we have got the numbers are positive. What does positive mean? That means the function is increasing in that interval. Okay, let's move to half. If I put half into here, what will I get? 8 multiplied to half, it is positive. Half minus 1, of course, if you take 1 from half, that will be a negative number. Half plus 1 is positive. So what do we get? In general, we will get a negative number. What does a negative number mean? That means in that interval from 0 to 1, we have got the function is decreasing. Okay, let's check on 2. Okay, that interval. Let's see if it is negative or positive. Okay, if I put 2 into here, 8 multiplied to 2 is positive. If I put 2 into here, 2 minus 1, it is positive again. For the third interval, bracket, we get that 2 plus 1 is again positive. So these ones multiplied together, we get a positive number. What does that mean? That means in that interval from 1 to positive infinity, the function is increasing. Although it was not required from us to find the increasing and decreasing intervals, but we have to find them. Why? To check whether those points are relative, extrema, or not. Okay, because the critical numbers will change to relative extrema. Okay, let's look at minus 1. You see that from this side of 1 the function is decreasing, and then from the other side it is increasing. Look, it's increasing and here it's decreasing. So what's that point? It is minimum point, so that one is relative minimum. Look at here, 0. Check whether it is maximum or minimum. If you look at the left hand side, it is increasing, and then from the right hand side the function is decreasing. So what is that point? That point is the peak, so that one is relative maximum. Look at 1. From that side it is decreasing, it's coming down, and from this side it is increasing, going up. So that point is what? It is relative minimum. And that is the required. What was required from us? It says find the critical numbers and then classify the critical numbers, whether they are relative extrema or not. We found the critical numbers. Okay, how did we find them? We found the first derivative of the function. We found those numbers that makes the function equal to 0 or undefined. Look, we found those numbers that makes the first derivative equal to 0. The numbers were 0, 1, and -1. When we find the critical numbers, we have to put them on the real number line, okay, in order, of course. We have -1 first, 0, and 1. Then from each interval, if you look at those 3 numbers, we have got that big interval, real numbers. It changes it to, it subdivides the interval into 1, 2, 3, 4 intervals. We are choosing a number, a test number from that interval. We chose -2. We choose another test number between -1 and 0, that was -half. We choose a test number from that interval 0 to 1, that's half, and a number that is greater than 1, it is 2. Okay, so then we classified, what did we do? We put those test numbers in the first derivative of the function to check whether the signs are positive or negative. What does positive and negative mean? Negative means that's less than 0, positive means greater than 0. We said if it is less than 0, the function is decreasing. If it is greater than 0, it is increasing. And then we found the intervals of increasing and decreasing. Then we looked at the critical numbers, whether they are maximum or minimum points. According to the decreasing and the increasing of the functions, we could classify the critical numbers as relative extrema. And that was all about chapter 3, section 1, and an example that includes all the subject: increasing, decreasing, relative extrema, and critical numbers. Hope you've understood the subject. And of course, as I told you previously, any questions, I will be available for you if you want online, if you want by sending an email. I'll be, of course, helping you. Have a good time. Bye.